Hello, so this lesson covers systems of equations. All right, so let's start with a warm-up, reviewing graphing equations that are in slope-intercept form. Remember this plus 3 is where it crosses the y-axis because our slope-intercept form is y equals mx plus b, and this b is where it crosses. So plus 3 would be right here. So we're going to put a point there. And you only need 2 points to be able to graph the linear equation. Our slope is -2. All right, so the slope, m, is -2. So we're going to do rise over run. We're going to put a 1 under that. So that means we're going to go down 2 over 1. So there's another point right here. Then you just connect the line or the dots. You could extend it past and go through. Trying to draw it as best as I can. So there's the graph of that linear equation. Hopefully you remember that and that makes sense. All right, let's go ahead and look at the next part. So essential question is, how will I determine the solution of the systems of equations? Today I am identifying and checking the solution for two graphed equations so that I can determine the solution of the system of equations. I'll know I got it if I can interpret the graphs to determine the solution. Okay, so here it is. So a system of linear equations is two linear equations that are graphed on the same coordinate plane. Here's an example here. You have the red one, which is y equals 2x minus 3, and the blue one, which is y equals -3x plus 2. The solution to the system is the point that makes both equations true. So in other words, the point where the line passes through both. And so it's right here where they cross. So don't overthink this. It's just where they cross is the solution to the system of this linear equation. So it's 1, -1. And you can always check by plugging in. And I'm just going to do that because it's good practice, because if our x value is 1 and our y value is -1, that first equation we would put, I'm sorry, let me back that up. We're going to put in the points or the values so the y is -1 and then the x value is 1, and then you simplify to see if that statement is true. -3 plus 2 is equal to -1. That is absolutely true. If you do the other one, the y value is -1, x value is 1. Oh, it's -3, not +3. All right, so -3. And so that simplifies to 2 minus 3, which is correct. So just a real quick check there. All right, so when you have systems of equations, here are the three types. One solution, they're going to cross, and that's going to be the solution. No solution, they're parallel, they'll never ever touch, so there's no solutions. Now this one, it's hard to tell, but there's actually another line that they've placed on top. So if that's the case, it's infinitely many. Every place on that line is a solution for both of those. So let's look at this. So if we were in class, I'd have you use your pointer. So I'd say, what is the one that has one solution right here? Infinitely many here. You can see the red and blue. No solution here. All right, so just make sure you understand that. These will never cross over here. No solution. this is one solution. And then the other one here is infinitely many. Sorry about that messy writing. Trying to get that on there quick. So we have a lot of slides to cover. Okay, so what is the solution? Well, here's where they cross. My x value is 1. My y value is 3. So that point where they cross is 1, 3. Answer is D. All right, so Frank and Erica are selling ribbons to raise money for the football team. The graph shows the number of days that they have been selling ribbons. On which day does it appear that Frank and Erica will have the same number of ribbons left to sell? It's where it crosses right here. Don't overthink that. So if you look down, our X here, and that's all we're asking for, because here this is days. So it's 18 days. So the answer here is D. Okay, so this is interesting. We already talked about it though, right? They'll never meet. They're parallel lines, so it's no solution. No solution. All right, so the graph models the linear relationship between the charge for a trip and the number of miles driven for 2 taxis. So we have taxi 1, taxi 2. This is where they have the same cost, okay, or distance versus the distance and the charge. So in 5 miles, it's $20. So that's where they're the same. So let's look. The charge for a trip with distance of 5 miles is $5 greater. No. It's the same at 5 miles. The charge for a trip with a distance of 5 miles is $5 less. Again, no, it's the same. The charge for the trip with a distance of 5 miles is $20 for both taxi 1 and 2. Absolutely, that is it. If you look at D, the charge for a trip with a distance of 5 miles cannot be determined. Yes, it can. We'll read the graph. Solve by graphing. Okay, so practice graphing. I'm going to do this top one in blue. Remember slope-intercept form, this plus 3. We're going to put that point on the y-axis, the 3, because remember that is 0, 3. It's where it crosses the y-axis. Then my slope is -5/3. So we're going to go down 5 from this point, 1, 2, 3, 4, 5, and then over 3, 1, 2, 3. So we're going to put that point, where did I lost it? 1, 2, 3, 4, 5, 1, 2, 3, right here. And we're going to connect those dots with my blue line. I don't know, we may have to go further, trying to be accurate here. So next one I'll do in green. Our y-intercept is -3. So we're going to put a point on the y-axis at 0, -3. Then my slope is 1/3. Sorry, my throat is dry. So we're going to go rise over run. We're going to go up 1 and then over 3. Oh, wow, look at that right there. So that is the solution for the systems of equations. So that point is at, here's my x, it's 3, my y is -2. That. All right, we're not that. That's for class. Okay, so you do have the opportunity to do a class kick activity. you can email me if you do complete that, and you will get Narwhal bucks for completing it. So I'm going to skip that. So here's our last one. What order pair represents a solution to both of these? Okay, so you're gonna, looks like it's right there. So let's try to determine. Some of these graphs are easy for Ms. Horton to read. All right, so looks like it's 5, 3. So it would be B. B is the correct answer for that one. All right, hopefully that all makes sense to you. Remember, you can pause, rewind, go back, jot down questions you have, and email me with any questions. So what are we doing today is for your lesson in the OMS. Well, we got a busy week with lots of quizzes. Goodness, goodness, goodness. So, oh, I don't think that is the correct one. So, sorry, the dates are off. This was not updated. You do have a 4.06 on your lesson for today, and there is a quiz. Reach out to me if you have any questions or need help.